can't you?
Yeah.
What's the biggest number we get out of here? 3, right? 3. So I shouldn't go any higher than 4 here. I could actually even go to 3 if I want. 1, 2, 3. Let's say that's 3. And now I try and graph this. I recommend we start with the numbers that are easier to graph. I would say these. Like graph that, graph that, graph that, graph that. So 0, 1 is this point right here, which we had talked about. That point will be on all graphs, all exponential functions. That's the point 0, 1. And then when I go to 1, I need to go up 1.45. So about right there. At 2, I go up to 2, a little bit past 2, 2.1. And then at 3, I go up a little bit past 3. See, I'm just like getting ballpark. It doesn't have to be perfect. And then it goes like this. And then to the left, it's hard to draw those decimals, so just do what you know is going to happen, which is going to die down, and it has an asymptote over here. If you do that, I'll be happy. Good? Okay, next problem. So for the next one, if you put $5,500 into a simple interest account, so $5,500 in simple interest account at an interest rate of blah, blah, blah. So I'm going to use this formula right here. So we're putting in $5,500. That's the amount we start with, right? So that's P. So we put 5,500 here. And then it'll be E raised to the, okay, our interest rate was 3.275%, right? But in the formula, remember, you have to convert that to a decimal. So we move the decimal point 2 places to the left. And so this should be 0.03275. But then I have to multiply that number by what? The time. 6. Just like that. Now, depending on you and your calculator, you might be able to type all of this in at one time, or you might have to do it in pieces. Please make sure you do this before you sit to do a test. Like, don't come to class to take the test and be like, well, this is the first time I've ever used it, because I'll be like, well, that's very sad. I'm sorry to hear that. And that's all I'll say. So I'm not going to help you on the test day how to figure out how to use your calculator. All right, I think I'd like to just get the answer, and then if you have trouble getting this answer, then when we finish today, I will help you on your calculator. I just want to go straight to the answer, though.
6694.24.
Yep, 6694.24, and again, we're rounding to the, these are pennies, right? Like, this is like 24 cents. So this is money, right? This is how much we have. $6,694.24. Done. That's pretty quick, right? That problem's pretty fast.
Showing our work just like that on the test.
If you just write that, I'm okay. Yep. Because truly, this is a problem you don't even need to write anything. You just type it in your calculator and get the answer, as long as you write everything in correctly. All right. Again, if you have problems getting that on your calculator, just after class, I can help you with that. Let's get on to number 4. So the difference between that problem and number 4 is that on number 4, I give you how much you're going to put in, right? So I'm using this formula again. The amount we're going to put in is what? 12,000, okay? E to the, all right, do we know the interest rate? 5.2, so we convert that to a decimal. 0.052, right? 0.052. Do we know how much time, though?
No.
We don't know the time, so we'll just put T here. And what do we want this to become at the very end? What do we want the final amount to be?
20,000.
20,000. Here we go. That's a completely different problem than this problem, right? Here, we had all the numbers we needed. We just typed it in our calculator. here we don't have what we need. We need to figure out what t is. And so that's where we brought in this whole idea of this natural log in our calculator and all that, right? So to do this, the first step you have to do y'all remember? First step? Before you bring in your calculator. Oh, wait, sorry, this is 20,000, not 2,000.
You have to combine the 12,000 with
Here, can't, no, careful, don't do that. You want to get rid of this, but not by multiplying. You want to divide both sides by 12,000 first. Okay? Divide both sides by 12,000. So you're going to take 20,000 on your calculator. You're going to divide that by 12,000. 1.666. Uh-oh. 1.66. Let's just, you want to just do 666? Do you mind? Let's do 666. Okay, 0.052t. All right, let's see if anyone remembers what to do now.
divide by 0.52 or 0.052.
Do what?
Oh no.
You want to say something? Okay, so how? How do we change this to the log? Do y'all remember? Dun, dun, dun.
We just
It's like 0.052.
Yeah. Okay, let me do a refresh. I think y'all are there. Some of y'all are there. Some of y'all aren't. Okay. Do you remember the loop? Does that sound familiar? The loop. When we write something like this, this means.
we do log e2.
Yep. Hold on. This means that when you take a and raise it to the y, you get x. In other words, when you take this and raise it to that, you get this. It's just a different notation. It's not important that we understand all this. We just need to know the mechanics of getting the answer. So if I have something to a power equals something, is that what we have over here?
Yes.
Something to a power equals something, right? Something to a power equals something. What I want to do is rewrite it using this. Log,
e to the 1.
and then the base down here, that's this number right here, is going to be the e that we have here. And then
X is 1.66.
we go 1.666 here. And then this side is what? 0.52t. This is the way it's going to work every single time that we do this problem. When you get to this step, we do this. Now, let's just check. If I take e and raise it to this, will it be equal to that? Is that what that equation says?
Yeah.
E raised to this, e raised to that, equals that. So this and this mean the exact same thing, is what I'm getting at, according to what we briefly learned about logs. Which means, at the end of the day, this is something we can do on our calculator. So we just do, what is the key that we use for this? The ln, actually, but it's okay. It's ln. Remember French? The French say it backwards. Instead of natural log, they say log natural. So that I've circled right here just means this on your calculator, and then here we just leave this. Now on your calculator, you have to find your natural log key. You've got to do natural log of 1.666.
0.5104.
Yep. So I get 0.5104 equals 0.052t. And there's one more step.
You divide the 0.52.
Yep, divide this side by 0.52, 0.52, 0.052. So 0.5104 divided by 0.052, get about 9.82. 9.82 is equal to t. And this will be years. It will take almost 10 years to turn $12,000 into $20,000. at an interest rate of 5.2%. May I erase? Over there? Where are we now? Systems of equations, right? We're ready at like last week's stuff. So systems of equations. First equation I'm going to give you, let's go with 5x minus y equals 10. And then let's go with x plus 3y equals negative 8. Now look, I just made this problem up on the fly, just in my mind. So there's no promise that these are going to be good numbers, all right? We need to solve this system of equations. I think we were pretty much almost unanimous last class that we liked elimination, right? So if you were doing this problem, would you choose to try and make the x's go away or the y's? The y's? And some people might do the x, right? You can actually do it either way. Like if I wanted the x's to go away, what would I need to do to make the x's go away? Multiply the second equation by, careful, by what? Negative 5. That way it becomes negative 5x and they go away. But the y's are actually a little easier because I can make the positive 3y cancel with this if I multiply this by what? Just 3. So let's do a vote hands. X's or y's? So x, y. Okay, let's do y. So we're going to multiply the top equation by 3. And that's going to go through to everything, right? So my new system becomes 15x minus 3y equals 30. And then I still have x plus 3y equals negative 8. Yeah, we're going to get fractions here. Sorry. After we've done that, what now? Yep, add them down, right? Just add down and see what you get. 15x plus x is 16x. The y's will cancel, that's by design. And then over here we get 22. 30 take away 8, 22. And then you divide by 16, you've got your x. And we can go ahead and get it as a decimal if you want. What's 22 divided by 16? 11 over 8. 1.375. Once you have that, you go find y, right? And to find y, plug that value for x into any of them. I like the second one. Y'all like this one? I like that one. Let's use that one right there. So I have x plus 3y equals 8, negative 8, sorry. And I know that x was just 1.375 plus 3y equals negative 8. And I can solve that for y by subtracting 1.375 on both sides. First, subtract first, don't divide, right? Subtract first. They go away. I get 3y equals, okay, this one's going in. All right. 3y minus 9.375. We're okay? Subtracting 1.375 on both sides. And now my calculator, I'm going to take negative 9.375, divide that by 3. I'm getting y is negative 3.125. Bless you. Y is negative, bless you. That's enough though. Who was that? Is that you? Oh, okay. All my markers are dead. What is going on? Yeah, don't. We spend way too much money on these things. These things are expensive. These little markers,
Yeah.
very expensive.
Hey, Black Friday's coming up.
Yeah, well, the department buys them for us. We have a huge tub of them, but we waste so much money on them. I wish we had chalkboards, old school.
Well, I think those are the way those sound.
Yeah.
For fucking your-
When I was in school, when I was a student, right, in graduate school, I would do homework in a room that we had for all the students would work in there and stuff. And I'd go home, I'd just be covered in chalk. It was kind of like coming home from a long day of work, you know. I'd feel like I'm dirty, like I've done stuff, you know. And now it's just these markers, yeah. But you know why they went to the markers? Is that a lot of rooms now have technology in them, and the chalk dust was messing up the computers. So, because chalk's much cheaper, much cheaper.
Yeah, it's pretty
All right,
cheap.
I'm digressing. We done? We have our answer? Okay, let's look at the next problem. It's another system of equations. But this one, I wanted to make it a little bit more challenging where it wasn't so easy to make the x or y go away, so let's do one like that. There's not a huge difference between this and what we just did, but enough of a difference that let's go with yeah, definitely going to get fractions here. I shouldn't say definitely. Pretty sure it's going to be fractions.
What do you want?
All right, do y'all see the problem with this one?
Yeah.
It's like it's not super easy to make the x's go away, not super easy to make the y's go away. You're going to have to multiply both equations by numbers to make them go away. I'm going to go after the x's.
Yeah, that's a good plan.
So I look at the two numbers, 5 and 2. So a common multiple of that is 10. So if I could make them both 10s, but opposite in sign. So I'm going to multiply this top equation by 2, right? And that will make this a negative 10x. I need this to be a positive 10x, so I multiply the bottom one by 5. And that will give me my new system of equations, and then I should be in business. Did I tell y'all who came up with this method?
Yeah.
Yes? Gauss, right? I did say it, okay. There we go. So I multiply the top row by 2. Did I do that right?
Yeah.
2 here, 2 here, 2 here.
Yeah.
And then the bottom by 5, so
Yep.
yeah, okay, just double check that, make sure you got that right. And now we should be able to add straight down. And when I add down, the x's go away by design, that's what I wanted. And then here I get negative 8y equal negative 13. Dang it, oh well. It's gonna be a fraction again, or decimal. There we go. Divide both sides by negative 8. You should get a negative over a negative here, right? So that should be positive.
1.625.
1.625. Good. 1.625. Not that bad, yeah. It's not repeating or anything like that. Now what?
Now you plug it in.
Plug that into any equation I want. I'm probably going to start with one of the ones I haven't touched. Like these are just uglier now because they're bigger numbers. Go with one of these, and I don't know. What do you want? First one, second one?
Second.
You want second one? Take that one and write it down first. How are we doing on time? Oh, we good. We made up some time here. So got 20 minutes left. Replacing the y, not the x, replacing the y with 1.625 and equals negative 3. So just make sure now that when you solve this equation, you do things in the proper order. I first have to take 4, or negative 4, however you want to look at it, multiply it times that. So this becomes 2x take away 6.5 equals negative 3. What now? Yeah, add. Add 6.5 to both sides. We get 2x equals 3.5. Divide by 2. 1.75. We're done. We're going to have time to spare. May I erase? Anyone need this? I'll start over here. So I was in my college algebra class earlier, before your class, and we were talking about something. It's kind of an interesting conversation. So do you all know that normally when things heat up, they expand? You all seen that? Like, y'all are aware of that? I don't know if y'all have ever seen like bridges. You know when you're driving over a bridge, there's usually like a groove, and you like drive, and it's like you go over. I don't know. Sometimes you can see like little teeth. Yes. Oh, sorry. Right. So a bridge, when it heats up from the sun, will expand and contract. So they have to leave a gap so that it has space to expand to. If you don't leave a gap, then it can, it'll break basically, right? So you have these things, they're called expansion joints. So most things on Earth, when you heat them up, they get bigger, and then when you cool them off, they get smaller. But there's one thing on Earth that doesn't do that. Well, there's a couple, but there's one really important one that doesn't do that. It does the opposite. When you heat it up, it gets smaller. When you cool it, it expands. And this one particular thing that does that is the reason why there's life on this planet. You don't know it? Water. Water. So when you freeze water, right? When you freeze water, you create ice. And when you put ice inside of water, it floats, doesn't it? Well, if it did what everything else did, what happens is it should be the opposite. Okay, so it should be the reverse. If it acted like steel or wood or any other plastic, if it behaved like that, then the reverse would happen. The ice cube would actually go to the bottom, not to the top. And for that reason alone is why life has been able to exist on this planet. Think of like the little lake we have there, or whatever the hell you want to call that. Let's say a pond up north, right? What happens is you got fish in here, and what happens when it gets really cold? You get ice, right, up here on the top, right? And believe it or not, that ice layer is actually what prevents the fish from dying, because you have the heat from the center of the earth that comes up through the ground into the water here. There's little heat, not real hot, but hot enough to keep the water from freezing. And this ice acts as a blanket and kind of keeps that heat in. If it was the reverse, if water acted like mostly every other substance on Earth, then what would happen is the ice wouldn't float to the top initially. It would start at the bottom, and you would get these layers of ice forming on the bottom. And the layers of ice would get thicker and thicker and thicker, and there's nothing to keep the heat in anymore, so it would just start to freeze from the bottom up, and eventually you got fish flopping around on ice and they die, right? So no life, because it'll just become a solid block. And so nothing can survive. So back during like ice ages and stuff like that, we had this scenario happen where things were able to live. And if it were reversed, then we all wouldn't be here. Well, depending on what you believe, right? Depending on what you believe. But, all right. Random useless information. Let's keep going. Last problem. All right, you plan to mix a 70% acid mixture or solution with some 8% acid solution to create 3 gallons of 40% acid solution. We did this for last class. You had, what, 3 or 4 problems to take home to do? What did I give you, 2 or 3? 3? 5? I give you 5? Okay. So how do we do this? We let X be equal to the number of gallons of the, what, 70% that we're going to throw in there. Let's let y be equal to the number of gallons of the 8%. So we have two unknown variables, x and y. One of them is how much of the 70% solution we're going to pour in. The other one is how much of the 8%. Now, at the end, we want 3 gallons of 40% solution. So we should be able to set up these equations. Since you did the homework, this should be pretty straightforward. Let's see. What can you tell me about x plus y? That has to be 3, right? The number of gallons of the x plus the number of gallons of y, that has to be 3 because I told you it needs to be 3 gallons. Then what you have to do is you have to figure out what you want at the end, right? At the end, you want 3 gallons of how much percent? Of 8, of 40%, right? You want 3 gallons of 40% at the end, right? At the end of it, you want that. So what we did is we took this 3 and we multiplied by 0.4, and that 0.40, convert that to a decimal. You multiply that and that gives you 1.2. This is how much acid, not total gallons. This is how much of it needs to be acid at the end. So that becomes this number 1.2. And then this right here, this number is going to be the x, but what goes in front of it? 0.7, the 70%. 0.7 in front of that, and then plus now the y, what goes in front of that? 0.08. You have to convert the 8% into a decimal. So it's the percentage converted to a decimal times x plus the percentage of the other one converted to a decimal times y equals the number of gallons we had at the end times its percentage. And those are your two equations. How would you like to solve this? You want to do the x's? How would you make the x's go away?
0.7 minus 0.7.
You need minus 0.7 here, minus 0.7 there. That way it would cancel with the positive 0.7. So minus 0.7 is going to go here, here, and here. The only difference between this problem and the previous ones when it comes to this part is that we have decimals. So negative 0.7x minus 0.7y equals negative 2.1. So I multiply each one of these by negative 0.7. And then here I get 0.7x plus 0.08y equals 1.2. We can add straight down. Be careful on the y's. Be careful on the y's. When you add these, what do you get? Because one of them is 0.7, the other one's 0.08. One of them's negative, the other one's positive. So just use your calculator, right? Do negative 0.7 plus 0.08.
Minus 0.62.
Minus 0.62. Y, right? Minus 0.26y equals 1.2. Sorry, no, I didn't add those down. Sorry. So these went away. This adds up to be this, and then these two together, that's negative 0.9. And now you should divide both sides by negative 0.62. Y is? What do you get? Oh, 1.45. Sorry, I thought I heard something. 1.45-ish? Y'all get that or no? Yeah, 1.45? And once you know y, you can go get x. And to get x, I'll use that first equation. X plus y is 3. And I know that y is 1.45. And subtract 1.45, you should get 1.55. 12:05. Yeah, take a picture. All right. So do you all feel like time is going to be an issue on the test?
Possibly.
Possibly. I mean, it took us roughly the entire class to do it, but I was also trying to explain steps as I go, so we'll see, right? Thursday, again, the plan is Thursday we come in, I'm going to hand you a test. That's a no-risk test, right? If you do poorly on it, no harm, no foul. You come in on Tuesday, that's the real test. Unless you do good on Thursday, you can keep that grade and you're off on Tuesday. You're off, you don't have to come on Tuesday or Thursday next week. We understand? All right, and then you have the review to go practice, and I'll try and get the answers to that to you. At a minimum, the answers, the pictures of the graphs and everything else. All right, so I will hang out. If you have any questions on how to do this on your calculator or anything like that, I'll hang out for a little bit. Otherwise, have a good day. See you Thursday. Be ready. If you try and take the test on Thursday, and in the middle of it, you're like, nah, this ain't happening, that's okay. You can let me know, and then we can move you to the other room or something. You can go work together. Let me turn off my camera real quick. All right. Have a great day, everyone.